Hello, my name is Aaron, and welcome to Introduction to Data Warehousing. In this course, we will cover topics such as what is a data warehouse and how it compares to similar sounding systems of a data lake and data mart. Next, we will look at data warehouse architectures and properties, including the different layers of a data warehouse. Additionally, we will review data warehouse data modeling, touching on the differences between effect and dimension tables and the differences between row and column stores. Finally, we will look at data prep and data cleaning, including the differences between ETL and ELT and the trade-offs between on-premises and cloud data warehouses. So, let's start with the fundamental question. What is a data warehouse? A data warehouse is a computer system designed to store and analyze large amounts of data for an organization. Let's add more context to this definition by describing what a data Let's add more context to this definition by describing what a data warehouse does. A data warehouse gathers data from different areas of an organization, such as engineering, legal, or operations. Then it integrates and stores that data and makes it available for analysis, similar to how a physical warehouse stores items and goods so that they are available for use later. Data warehouses have been around for a while. What makes a data warehouse valuable enough that an organization will invest time and money in creating one? Organizations implement data warehouses to support business intelligence activities, such as deriving key performance indicators. Analysts, data citizens, data scientists, and anyone else who needs to analyze the organization uses the data from the data warehouse as input for their analysis. Their analysis leads to organizational decision making with the goal of finding ways to innovate based on insights from their data. To better understand these concepts, let's look at an example. Meet Bravo, a hypothetically publicly traded company that sells fancy home office furniture. Let's explore some common scenarios where its employees might utilize a data warehouse. Bravo might utilize this data warehouse for product forecasting. Their data warehouse aggregates their historical sales by customer and product, which is the regulations and governs employees could prepare reports from firm Bravo's adherence to the rules. Finally, through analysis of their sales, Bravo noticed that their sales growth is accelerating in Asia. Therefore, HR and operations might use their projected sales growth in Asia. So, in summary, a data warehouse is a computer system designed to store and analyze large amounts of data for an organization. The warehouse becomes a central repository for clean and organized data for the organization. It does this by gathering data from different areas of the organization, integrating it, storing it, and then making it available for analysis. Organizations value data warehouses because they support business intelligence activities and enable analysis and decision making, fostering data-driven innovation. Let's check if you have Welcome back. This video clarifies the differences between a data warehouse, a data mart, and a data lake. They're similar sounding names that can be confusing. Most people are familiar with databases, so we will start with them. Databases use tables to store information in a structured way with rows and columns. Organizations use databases to store the different transactions that happen within the organization. We will call them transactional databases. For example, when a company sells a good to a customer, the information about that transaction is stored in a database. Now, let's look at a data warehouse. Data warehouses gather data from different areas of an organization, integrate it, and make it available for analysis. They are built as a central data store for the entire organization, representing many departments. Therefore, there are many data sources as inputs to the data warehouse, including multiple databases or even non-databases such as a log file. All this data is collected, transformed if needed, and integrated into a structured format into the data warehouse in an ETL process, or extract, transform, and load. We will talk more about ETL processes in a later video, but it is important to note that data in the data warehouse is structured into tables with rows and columns. This structure can make it complex to change because of upstream and downstream effects. Also, data warehouses are large, typically larger than 100 gigabytes. You might think, why not query the different transactional databases when performing an analysis versus using a data warehouse? Running queries involve analysis versus using a data warehouse. Running queries involving a large amount of data can take a very long time, possibly slowing down the database and restrict the data warehouse. Running queries involving a large amount of data can take a very long time, possibly slowing down the database and restricting it from its primary purpose of recording transactions. Now that we've discussed data warehouses, let's discuss data marts. A data mart is related to warehouses. Running queries involving a large amount of data can take a very long time, possibly slowing down the database and restricting it from its primary purpose of recording transactions. Now that we've discussed data warehouses, let's discuss data marts. A data mart is a relational database that stores an organization's transactional data for analysis. Data marts and data warehouses both hold structured data. However, whereas a data warehouse contains data from many different departments, a data mart only focuses on one department, such as just finance. Data marts have only a few input data sources versus a data warehouse with many. Often, the input source is a subset of data from a data warehouse. Additionally, a data mart is typically less than 100 gigabytes, which is smaller than most data warehouses. So, let's extend our understanding and discuss data lakes. Data lakes, similar to data warehouses, are built as a central store of data for the entire organization for analysis. Therefore, they store data for many different departments, have many input data sources, and are large. However, data lakes can hold non-structured data, such as videos or audio files. A data scientists might use this unstructured data in a model that analyzes video for production processes for quality control. Compared to data warehouses, it is easier to make changes to data lakes because of their flexibility in storing unstructured data. This flexibility also allows storing data whose purpose may not be known today, but may be helpful for future analysis. In contrast, when designing table structures for data warehouses and marts, organizations tend to know how they want to use the data for analysis. In summation, data lakes hold both structured and unstructured data, while the others only hold structured. Data lakes are easier to change, but may contain data with an unknown purpose. Data marts only hold data for one details. This video looks at the data warehouse lifecycle and the different personas that support the different stages. In this video, we will use hypothetical characters as personas and talk about the lifecycle stages in general terms. However, others might organize and categorize the stages diff project. At a high level, the first step is the planning phase, where the team begins to plan how to design the data warehouse to satisfy the organization's needs. Next, implementation phase, where the team builds the data warehouse. Finally, in the support and maintenance phase, the team trains end users and maintains. The first is requirements gathering. The goal here is to understand the organization's needs. Who and how will they use the data warehouse? To support this task, meet Christina, a data analyst, and Alex, a data scientist. Christina works closely with others in the business, and her analysis helps with decision making. Alex's ML models automate decision making and improve business processes. Christina and Alex are closer to the business and know their final goals and requirements best. Data modeling is next. It is planning based on business requirements. Data modeling business and improve business processes. Christina and Alex are closer to the business and know their final goals and requirements best. Data modeling is next. It is planning based on business requirements on how the team transforms data from the different input sources and integrates it into our data warehouse. Crucial is that the team understands and links the relevant data sets. To support this stage, meet Stacy and Derek. Stacy is a data engineer and is skilled at creating data pipelines. Data pipelines are automatic, end-to-end processes that collect, modify, and deliver data. Data pipelines from Alex use their business knowledge to support this stage by helping ensure that the data model accurately represents the organization. Within the implementation phase, the teams design the ETL process. This step is about designing and building the data pipelines that extract, transform, and load data from the different sources into the data warehouse. Stacy is responsible for creating the pipelines, but she coordinates with Derek to extract data from the source systems. After the team loads the data into extract data from the source systems. After the team loads the data into the warehouse, they work on BI application development. In this step, they set up BI or business intelligence tools to interact with the data warehouse and create reports needed by the organization. BI tools are often how many users interact with the data warehouse. Some standard BI tools include Tableau, Power BI, or Google's Looker. At this point, Christina and Alex consult on the setup with the BI applications. Christina import and maintenance phase. The teams can update the warehouse table designs or make other necessary changes. Stacy makes these changes if required. After this step, we get to testing changes if required. First, Christina and Alex test the system. We get to testing and deployment. First, Christina and Alex test the system to confirm their business requirements are met. Afterwards, Stacy will deploy and make the warehouse available to the organization. After deployment, any significant changes will follow the same steps, starting back at the planning phase. In this video, we have covered a few persona planning phase. In this video, we have covered a few starting new personas that support the data warehouse lifecycle. This chart summarizes when the different personas are needed. The list contains only the leading data-centric roles involved. For example, we ignored roles like project managers. Finally, additional essential personas are the organizational leaders who sponsor. Welcome back. This video will discuss data warehouse architecture and the four layers of source, staging, storage, and presentation common to many warehouses. Initially, we will start with a view of the overall data warehouse process and the different layers. Then, we will review each layer in more detail afterward. The first layer contains the data sources for the data warehouse. Then, the data is extracted, transformed, and loaded through an ETL process. During this process, the ETL view here any data user in the data presentation layer. Business intelligence or other analysis tools connect to the warehouse and allow the end user to interact with the data. To add more context, let's look at each layer in more detail. The data source layer includes all the different sources for the data warehouse. The data sources can include different data types, such as files and databases. Recall that this will also include transactional databases, which record the various transactions that happen within an organization, such as the sale of an item to a customer or the hiring of a new employee. In the data statement, or the hiring of a new employee. In the data staging layer, the source system's data is extracted, transformed, and cleaned before being loaded into the next layer. The staging layer includes the ETL process and a staging database that stores data temporarily during this step. Next, we will examine ETL process more closely. ETL, we will examine ETL process more closely. ETL, again, stands for extract, transform, and load. First, the process extracts the data, transform, and load. First, process extracts the data from the source systems, then transforms it by applying extracts the data from the source systems, then transforms it by applying business rules, which clean the data and may include transforms it by applying business rules, which clean the data and may include mathematical operations such as which clean the data and may include mathematical operations such as averaging different rows together. It uses staging tables here to store the results in rows together. May include transforms it by applying business rules, which clean the data and may include mathematical operations such as averaging different rows together. Mathematical by applying business rules, which clean the data and may include mathematical operations such as averaging different rows together. It uses staging tables here to store the results between the various transformations temporarily. The data in the source layer can have many different formats. including even unstructured. Regardless of the format, to be valid input to the warehouse, the ETL system must be able to extract data that can be placed in rows and columns. An example is extracting the email address from unstructured document like an email. The staging layer outputs data that is ready to be stored. The data can be loaded to the next layer in batches or all at once. In the data storage layer, data pipelines store the staging results in the data warehouse and data marts. Depending on the design, data from the ETL process will be stored directly in the data warehouse and then into the data marts. In other designs, the opposite happens, where the data moves to the data marts first and then to the data warehouse. We will explore this more in a later video. In the presentation later, we will explore the in the data warehouse and data marts. Depending on the design, data from the ETL process will be stored directly in the data warehouse and then into the data marts. In other designs, the opposite happens, where the data moves to the data marts first and then to the data warehouse. We will explore this more in a later video. In the presentation layer, users interact with the stored data. Queries are run in this layer to facilitate analysis. This layer includes BI or business intelligence tools, data mining tools, and direct user queries, some of which have graphical user interfaces to visualize query results. We will discuss this layer more in the next video. In closing, data moves from the different sources in the next video. In closing, data form or data to the warehouse, adding value to the organization. Time to test your knowledge. This video will examine how users interact with the data within the data warehouse and some tools used within the presentation layer. To start our discussion, users interact with the warehouse data in the presentation layer, an area of constant development. The interact with the data within the data warehouse and some tools used within the presentation layer. To start our discussion, users interact with the warehouse data in the presentation layer, an area of constant development. The industry is constantly evolving to make the tools used in the presentation layer easier to use and provide more capabilities. Therefore, understand the information in this video as general trends and not as rigid rules. We will group user interactions within the presentation layer into 3 categories to organize our discussion. The first are tools that can produce automated reports or are used for dashboarding. Next, we place business intelligence or BI and data analytics tools into another group. Users use these tools to explore the data and find patterns. These tools may have a graphical drag and drop interface. The final group is directly querying the data warehouse. Here, users use their ability to write SQL queries to create custom queries to look at the data. One of the greatest benefits of custom queries to look at the data. One of the greatest benefits of having a data warehouse is the ability to automate reporting and create custom dashboards. The data warehouse creates a central repository of data for the organization that can be queried. Using tools to create reports automatically or update dashboards can save users such as analysts a significant amount of time and help keep the organization informed. Examples of tools that would fall into this category include Tableau, Power BI. And data scientists are often charged with setting up these reports. These tools tend to have a graphical user interface with little coding required to use. This makes the data within the data warehouse available to users with a limited coding background. BI and data mining tools are often used to explore the data. BI and data available to users with a limited coding background. BI and data mining tools are often used to explore the data and uncover patterns. Analysts or data scientists are likely to use these tools to convert the data into actionable insights. For example, sales transactions can be considered data, but identifying that the sales totals are down in a particular region can be regarded as information. These tools can vastly range in user interface complexity. Many still use graphical drag and drop, although they can also allow users to write code directly. The tools highlighted for reporting and dashboarding could also fit into this category. In addition to those, tools such as Oracle Data Mining, RapidMiner, Alltrex, and Nine are focused on data analytics and mining. In our final category, we have direct queries, analytics, and mining. In our final category, we have direct queries. SQL is often used to query the data warehouse. Here, users can compose their own queries of the data warehouse. A data analyst, data scientist, or data engineer with greater technical skills may want to use more advanced tools. Examples of tools in this category include SQL Server, Management Studio, Azure Data Studio, and the popular programming tools of R and Python. These tools offer great flexibility in using the data warehouse to explore questions. In addition, R and Python offer additional packages to do other sophisticated analysis of the data. As we continue to learn more about data warehousing, it is helpful to know the types of tools used by users and how they interact with the data warehouse. Okay, users and how they interact with the data warehouse. Okay, practice time. Welcome back. In this video, we consider two data warehouse architectures. The first architecture we will discuss was popularized by Bill Inman, also known as the top-down approach. Bill viewed the data warehouse as an Inman. In this video, we consider two data warehouse architectures. The first architecture we will discuss was popularized by Bill Inman, also known as the top-down approach. Bill viewed the data warehouse as a tool to contain all of the organizational approach, as was popular data warehouse architectures. The first architecture we will discuss was popularized by Bill Inman, also known as the top-down approach. Bill viewed the data warehouse as a tool to contain all of the organization's data. Essential to this architecture is that the organization must decide on the naming, the definition, which data is valid if there are conflicts, and all other data cleaning operations on all of the data before it enters the warehouse. Additionally, on all of the data before it enters the warehouse. Additionally, this architecture stores data in the warehouse in a normalized form. Data normalization is a way of organizing data to reduce data redundancy and improve data quality. The data then moves to a department-focused data marts where end users and applications can query it. This approach has some advantages. First, the formula input sources into a single definition that the organization agrees upon makes the data warehouse an effective source of truth. Furthermore, since the data is normalized within the warehouse, less storage is needed, and creating new data marts for reporting or analysis is relatively straightforward. However, Because the data is normalized, it requires more joins for reporting, leading to slower response times, which is one of the disadvantages of the top-down approach. Additionally, as you might imagine, gaining alignment by the organization on the data definitions could take a lot of upfront work, resulting in a higher startup cost for warehouse projects. Ralph Kimball popularized a higher startup cost for warehouse projects. Ralph Kimball popularized the next popular data warehouse architecture, also known as the bottom-up approach. In this approach schema, a star schema is a way of storing data that makes query writing fast and straightforward. In the Kimball approach, the focus is on getting from data to reporting as fast as possible. This is done by first organizing and defining the data definitions of one department of the organization, placing that data into a data mart and making it available for reporting. After completing one department, a new department is chosen, and the cycle repeats. Various data attributes, departments chosen, and the cycle repeats. Various data attributes, such as tools of the bottom-up approach, include how fast it can get up and running by taking an incremental approach, resulting in lower upfront costs on warehousing projects. Also, the denormalized data model makes the data easy to consume for users. However, denormalization increases the processing time within the ETL process and can create duplicate data when used across different data marts. For example, if the organization includes a field name revenue in two data marts, but in one the revenue accounts for a cost of goods while the other doesn't, duplicate data can confuse and make the data warehouse less of a source of truth. An additional disadvantage is as the organization adds new departments or processes, more development will need to be done. The bottom-up approach has a lower upfront cost but requires more upkeep than the top-down approach. So when developing an architecture, it is essential to create one that works for users while being aware of their strengths and weaknesses. Time to check our while being aware of their own Hello again. Let's continue our discussion on data warehouse architecture. This video will focus on another core component of data warehouse implementations called OLAP and how it compares to OLTP systems. OLAP stands for Online Analytical Processing. It is a tool for performing multidimensional analysis at high speeds on large volumes of data from data warehouse, data marts, or some other centralized data store. They are optimized for analysis. In data warehousing, most organizations have data organized into different dimensions, such as sales figures by country, state, and city. Another dimension example is time, broken into years, months, and days. Data warehouses store data in rows and columns. OLAP systems take this two-dimensional representation of data in rows and columns and reorganizes it into a multidimensional format that enables fast process call with OLAP systems. At the core, analysts typically work with OLAP systems. At the core of the OLAP system is the OLAP Data Cube, a multidimensional database that makes it possible to process and analyze multiple data dimensions in product. Width and length will represent where these edges intersect each dimension. In this example, the dimensions are region, year, and product on the selected hypercubes. So now, let's talk about OLTP. OLTP stands for Online. Let's talk about OLTP. OLTP stands for Now, let's talk about OLTP. OLTP stands for Online Transaction Processing. These systems are optimized for processing a large volume of simple database transactions and queries as quickly as possible. Typical uses. In these examples, the OLTP system processes simple queries to the database, like inside systems tend to have systems are often critical for the business and not use databases or the source systems that feed into the data warehouse. Now, let's look at systems that feed into the data warehouse. Engineer at a credit card company. He is responsible for maintaining the OLTP. This system was designed to track thousands of purchases and their updates every second. However, this system was not designed to analyze customer purchasing patterns. Instead, Eli's team uses a data warehouse and an OLAP system that tracks purchases by year, customer age, location, and time of day. Analysts within the company use this data to make business decisions. In summary, OLAP systems are designed to support data analysis. They execute complex queries of multiple rows or transactions faster than a traditional relational database. The core of the OLAP system is the data queue, which represents the data in multi-dimensions, allowing for data slicing. Comparatively, OLTP systems are designed on one or only a few rows of data. The core of these systems is the database table, which stores the data in rows and columns. Alright, table which stores the data in rows and